Okay, so this video is going to go through properties of inverse functions and the idea that inverse functions undo each other. So one key idea is that for a function to have an inverse, the original function needs to be one-to-one. Okay, so that's a one-to-one function, and that's not a one-to-one function, so it needs to satisfy both the horizontal and the vertical line test, whereas that one fails. This is the property that I want to focus on, which is the composite of the inverse and the original just gives you back x. We should also know that inverse functions, you just swap the x and y values, and because of that, the domain and range swap around. Okay, so the first thing you might remember is that if you were solving for an angle in trigonometry, for a right angle triangle, you would say sine theta equals opposite and hypotenuse. And if I wanted to find the angle theta, you would take the inverse sine and you would get back 30 degrees if you're working in degrees. Now, really, what's happening is sine theta is a function. It takes in values of theta, and if we restrict it between 0 and 90, we can work out the different angles here. If I take the inverse sine both sides, then I'm just left with theta, and you get back 30 degrees. So the inverse sine undoes the sine. The inverse function undoes the function, just like up here. Okay. Now, the next example is going to be the following. Okay, so my original function is a quadratic which goes through 1, 1 and finishes at x is 2, y is 4. Alright. If I wanted to find the inverse function, the normal process is to swap the x and y's. Alright. And we should recognize that the domain and range swap as well. Okay, so let's first look at the domain of this guy is x between 0 and 2, and the range of this guy is written like this. The range of f is 0 including up to 4 not including. So the way that we find the inverse is we go at y equals x squared, swap them, and solve for y. Now you're going to get plus or minus root x here, and you need to choose the one that gives you the correct domain and range, or you remember is going to be the one that is a reflection in the line y equals x. So it happens to be the positive root x, and you know that the domain and range swap here, so the domain of this is the range of the original. Okay, and in general, if you're asked to find the inverse function, always write down the domain as well. Okay, so let's just check that this property works. Okay, so if I sub in the inverse into the original being x squared, do I get back x? So subbing in root x, you get root x squared, gives me back x. That works. The next one is this. If you sub in the original into the inverse being root x, so sub in the original, you also get back x. That's correct. Now, if you're asked to sketch f inverse of x, then you know it's the line y equals x, but there's a restriction on the x values. And really what's happening is that you have to work out the inside first. So the inside takes in values between 0 and 4 for root x. So from 0 to 4 goes into 4 not including, goes into the inverse and spits out values of 0 to 2 not including, and then that goes into f, and f has the domain 0 to 2 not including. So that's all good. It spits out values of 0 to 4 as your final values. So in this case, the output of the range of the inverse is a subset of the domain of the original. Okay, the domain of the original is from 0 to 2. So ultimately, what happens here is that we get the line y equals x as our answer. There's a restriction from values of y being between 0 and 4, the final output. So between there, and we're not including. Okay, that's it.